Hello, everyone. Welcome to today's webcast, Digital Twins, What Manufacturing Leaders Need to Know. My name is Kaylee Valandre. I'm a Senior Marketing Manager here at PTC, and I will be moderating today's discussion. A few housekeeping items to take care of before we kick things off. First, this session will be recorded, and the replay will be emailed to you within the next couple days. Second, we will be taking questions at the end, so feel free to add your questions in the Q&A box at any point, and we'll get to as many as we can before we wrap up the presentation. Lastly, there will be 2 polls during the presentation. We encourage you to participate. We'll review the results of the polls at the end of the webcast. Now for the good stuff. Today we're joined by 2 guests who are going to help us better understand the digital twin concept. We are thrilled to welcome Catherine Kniker, better known by her peers as CK. She is the EVP and Chief Strategy Officer at PTC and is responsible for overseeing key strategic functions, including corporate strategy, mergers and acquisitions, and corporate marketing. CK brings her strong business acumen, excellent systems thinking, and tech savviness to this role. CK will be joined by Ryan Martin. Ryan is a research director at ABI Research, covering new and emerging transformative technologies, including Industry 4.0, digital transformation, and the Internet of Things. He currently leads the firm's manufacturing, industrial, and enterprise IoT research, and recently authored a white paper titled Industrial Digital Twins: What's New and What's Next, which will be the focus of today's conversation. Ryan will share the findings of his research, which will be enriched by CK's years of experience as a tech strategy leader. And with that, I'll hand it off to CK to get us started.
Thanks, Kaylee. I'm really excited to be part of this conversation today. At PTC, we create digital solutions that help our customers transform their physical products and processes. With our CAD solutions, we help customers use digital to define physical. With PLM, we help customers use digital to manage the physical. And with IoT, we help customers use digital to connect physical, both for the products that they make and for the assets that they use in your factories. And with AR, we help customers use digital to augment physical, both for the benefit of their workers in the factories and out in the field. Now, despite the focus of this webinar, PTC doesn't actually have a digital twin product per se. Instead, digital twins are created by you, our customers, by leveraging all of our solutions together. You harmonize the digital definition of your products or processes with the product's physical experience and deliver it in a way that creates value for your stakeholders across the organization, specifically in engineering, manufacturing, and service. That's why I encourage all of you today to participate in the questions and polls, because digital twins are being created by you in your unique circumstances, not here in this conversation, as it were. It's also why I'm really excited to have Ryan join us virtually and share his research. Our success in delivering digital twin for you hinges in part on your understanding of what digital twins are and the many ways they can generate value at your company. That being said, let's jump in. Hello, Ryan. Welcome to our studio. We're really happy to have you here today. Maybe before we dig into all of your research, maybe give the audience a little context for why you did the research to beginning and your reasoning behind it.
Thank you for having me and happy to be here. Our research on digital twins is an ongoing effort. We've been covering this topic for several years now, and this body was to look at what is new and what is next for digital twins. As always, this was largely a customer-led effort, so we listened to our partners and the companies that we work with, and this is one of those topics that, especially going into the pandemic, and through a lot of it, started to become much more topical and important and more of a priority for companies to work with today.
Great. So maybe the best place to start, having got that context for your research, is what is the definition of a digital twin? You want to share what your research tells us?
Absolutely. Yeah. Digital twins are digital representations of real-world objects. They're deployed to drive business outcomes, and there are many different kinds. They range from what we call low fidelity digital twins to high fidelity digital twins. And an example of a low fidelity digital twin might be getting real-time sensor readings from a machine. A higher fidelity digital twin might be what you envision, where it's a full 3D digital representation with embedded simulation capabilities, and it's much more comprehensive in its execution or executable capabilities. Um, it's not a technology, but it's really a composition of technologies, and it results in a capability. So it's a composition of CAD, connectivity, cloud, industrial IoT platforms. Of course, you need physics-based simulation and probably a front-end device to internalize and use a digital twin. So this could be tablet, could be smart glasses, it could be a desktop.
Before your research, or maybe during your research, did you see a lot of disparity in the definitions that people are using, and is there any common disparities or common alignment maybe?
Yeah, I'd say one of the biggest changes that's happened in the last 24 months has been around the relation of digital twin and digital thread, where initially there was a conception or notion that it took multiple digital twins to create a digital thread. In fact, today that is completely reversed, where digital thread underpins digital twin. And digital thread is really about that having data continuity and data coherence across different domains, whether it be IT, OT, or even ET.
For sure, and in fact, here at PTC, we spend more time talking about digital thread than we do necessarily digital twin, because of that very, very reason that you brought up. It's the underpinning of creating value, which you create via the digital twin. But if you don't have the underpinning of the data, the twin is either can't be created, or it's actually not a correct representation, whether it's basic or advanced. And so one of the things we're finding is a lot of our customers, as they're on this path to digitally transform, one of the first things they all realize that they need to do is get their, as it were, their digital data house in order, which leads to a lot of projects, whether it's way back up in engineering or, like you said, OT. You mentioned ET. I don't think that's a term that's used frequently. Is that a new term from you, or have I been under a rock?
Yeah, you're right that the market for a long time has been talking about IT and OT convergence, which to me, that's actually a problem statement. I like to reframe that as IT, OT integration and collaboration, which is really what we're trying to achieve. But it's not as comprehensive as we may be led to believe. It also very practically should include engineering technology, or ET. And that's another side of the house. Other team members who are highly relevant to driving change, especially for digital transformation projects. And they need a seat at the table, especially for digital twins, which requires alignment, not just within a single team, but across teams, across functional areas and domains.
And I'm sure that's particularly true for manufacturers of physical products, where there is a lot of design data and a lot of digital definition of the actual product.
Absolutely. The digital definition is core to everything downstream that you can do with a digital twin. Initially, there was also a conception that a CAD design was a digital twin. I think today that notion has been debunked, where really to have a true digital twin, it does need to tie into a physical product. And then everything around that, if you really can underpin that ET definitional data with IT infrastructure, then OT actionability, that's when you start to get much more, when the capabilities are much more valuable and meaningful. You're getting beyond remote monitoring and maintenance, which really are key capabilities during pandemic when people are forced off site, and into virtual commissioning. So actually not just creating an assembly line, but saying this is going to work right the first time and then installing it.
All right, now that we've talked about what a digital twin actually is, I guess the next topic is what are the use cases? And so maybe before I ask you, Ryan, what use cases you see, whether they're use case by type of use case or use case by stakeholder, why don't we just do a poll with our audience and see what use cases they're interested in for digital twins?
Yeah, typically when we think of digital twins, one of the first places we see actual real-world use is around remote expertise or guided workflows. But to get to that, first you need to have this digital definition, which we've been talking about. That may be in the form of a CAD model or design work. So again, really this is not a true digital twin, but it is core to underpinning and enabling a digital twin. Different use cases that can be enabled once you are able to parlay with the physical model are, well, today they're around remote monitoring and maintenance. That's where industrial IoT and what we used to call machine-to-machine technologies kind of originated. In the future and where it's headed is getting more toward remote control. So not just knowing the state of a remote asset and maybe how it can be optimized, but actually being able to action that optimization.
Great. If you were to say where companies are today, if you take those types of use cases, what are you seeing in terms of the level of maturity?
I'd say most companies are still in the instruct and build and monitor and maintain type phases where they're doing a lot of diagnostic work. And this is especially important today when folks may not have the convenience of getting on site every day of the week. And it's actually critical then to business continuity to be able to know how your business is performing remotely without physically being there. Over time, I know that there is interest in more advanced capabilities, more prescriptive. So overlaying prescriptive analytics with a digital twin type mentality could be very powerful. It means that you're no longer sending workers to stations when they aren't needed, when they don't need to be there. It means you have the right people performing the right tasks, the right time, not retroactively, but in fact proactively. All these capabilities are enabled when employees at all levels of the organization have access to the right information at the right time and place, and digital twins help do that by getting everyone on the same page from a data perspective.
One great example here with one of our customers is Harpak Ulma. They're an integrated packaging company that deliver packaging solutions to whether it's medical device companies or industrial companies. And they've definitely are on this path. Primarily though, I'll say it's the remote monitoring, it's the diagnostic understanding how the machines are performing, but also they've added the AR component to really help on-site engineers either diagnose problems without somebody having to go on-site. So it's more those classic use cases, but it's leading to a company who delivers an integrated packaging solution having completely other value-add offers to deliver to the operators and the users of their equipment. So it's opening the digital thread and digital twin tech capabilities are opening up new business models to them. Are you seeing that in other places as well, or are people primarily using digital twin for internal optimization?
Oh, there's a lot of innovation happening on the business model side, especially for product focused companies. We hear about bearing companies wanting to sell rotation and motion rather than actual bearings, or elevator companies wanting to sell vertical lifting capacity rather than the actual elevators. And having real-time visibility into your operations and the assets that you're selling to customers and how they're performing in the field is tremendously valuable, not just to those customers, but their customers' customers. And that's what they're seeing, especially when it comes to business model innovation. You mentioned frontline worker enablement and support. Frontline workers represent 75% of the global workforce. That's 2.7 billion people. There's tremendous opportunity to support these professionals with new tools and business models that are aligned to the value that they're driving.
Yeah, for sure. I mean, it's one of the areas I think for a long time, there's been a lot of innovation for knowledge workers, but a lot of the frontline workers, there's just not been as much innovation. But I think we're about to see an onslaught of innovation, which is great because of both the volume plus the aging of some of that workforce and the turnover in that workforce. There's real life problems that many of our customers are encountering, and so being able to almost train on demand, being able to deliver knowledge just in time, I think it just opens up a whole new world of opportunity, and there's lots of exciting things happening in that realm. Great. So we talked about the types of use cases, Ryan. Maybe talk a little bit about the stakeholders and who's driving and who's getting benefit.
Yeah. So there are a number of beneficiaries of digital twin implementations across a few domains. We mentioned ET, IT, and OT. In this case, we can also single out actual manufacturers for whom digital twins provide critical data feeds across the entire value chain. Frontline workers, we mentioned 2.7 billion people, bringing the same kinds of productivity tools that their peers in other functions have had access to, but to them is incredibly important. Business executives to get better visibility into overall operations, plant level, system level type insights. Sellers of physical assets talked about new business model innovation, selling outcome as a service is categorically where I think a lot of things are going. And then also for software engineers, their digital twins can be used to accelerate time to market and overall iteration and agility between teams.
And maybe the same question as I asked you on the type of use cases. Are you seeing any stakeholder grouping getting more or less value? Like maybe which stakeholder group is getting the most value, and is there one stakeholder group leveraging digital twins more than the other?
Yeah, so this is an interesting question, and it sort of has to do with the way that companies are now employing and driving digital twin innovation. If we look at, again, 24 to 36, 48 months ago, we saw a company saying, we want to implement digital twins, and it was very much top down. Today, what we find is that manufacturers need better visibility into operations and want to improve OEE. And by the way, at the end of XYZ project, we have a digital twin. So it's kind of happening the other way, where it's value led, it's use case and solution led. And then by the way, at the end, because it's a compilation or composition of technologies, this is the capability that we end up with. And so who it's benefiting most, definitely operations folks and frontline workers. There's benefit to IT and ET as well. One of the biggest challenges, though, is driving alignment for those teams and actually seeing the benefit at the same time.
Yeah, we just a little while ago did a pretty good body of work. I believe we did it with Accenture, and where we looked at digital transformation projects. It wasn't digital twin per se, but when you double click, it was really about digital thread and the value that digital twins could unleash. And one of the big drivers of success, or at least it correlated with success, was having both top-down and bottom-up engagement. And because the single biggest inhibitor was siloed thinking and siloed data pools. And, companies, in some cases, data has been power for a long time, and just getting data across silos was probably the single biggest cultural change that needs to happen in companies. So, we've been here at PTC recommending that it's not just about the technology stack, it's you need to view this as a major cultural transformation and have both big time investment top down, but also your champions across the business. So it sounds like you're seeing the exact same thing.
Absolutely. Yeah. Data coherence maturity is incredibly important. It's one of the biggest challenges for driving these changes. I mean, getting everyone on the same team and working with shared models, not just shared data, but also shared innovation implementation cycles. A couple of tactics to do this. You mentioned putting how to functionally collaborate. I completely agree. Putting someone from one functional area onto the team of another functional area is a great way to do that. Also, we're seeing the rise of new roles. Chief Digital Officer would be one example. And there's certainly questions to be answered about how that role feeds into the others. But the theme is that there is a need for alignment and co-innovation across these teams, which have historically been not not very well aligned, and just by virtue of where budget comes from, how they typically innovate, the kinds of problems that they're trying to solve. And what this means is that the function that each department plays could very well change, and actually it has to change, it has to evolve.
Yeah, it has to change. Yeah. That's why I say it's actually far more than technology, and it's far more than data. It's really a cultural change, and job roles and what's the definition of success is actually has to change, because it's the greater good is more important than the specific functional or silo. And that's not easy, but I think a lot of companies are tackling that. And we actually have a bunch of good examples. One of which I've used before, but Chelly, which is a beverage dispenser company. So they design the beverage dispensers, whether it's for an alcoholic beverage or a nice cold soda. And they really took a step back and did a lot of the things that you're talking about, Ryan. They hired a champion from the outside to really look at how to digitally transform the business, both for themselves to get more efficient, but also for their customers. And they looked at the full digital thread, from how their products were designed, how they were managed through the process. They leveraged IoT and they leveraged AR to really deliver value, such that they were able to go from, I think they got 10% more production from their internal processes. They were able to change their business model, so they were able to offer insights to the actual company, whether it was a pub or a restaurant, to say you're going to run out of beverage X, Y, or Z. They were able to look at the quality based on temperature measurements. I mean, they fundamentally changed their entire business model, and it led to real bottom line results. But one of the core pieces, in addition to the technology stack choices that they made, which of course were PTC, no, I'm just kidding, but it was, one of the big changes was the cultural change and getting everybody invested and changing KPIs and metrics. So it definitely can be done, and there's plenty of examples of it. Maybe let's just skip to, and we've kind of started to touch on it, but like both the drivers and the inhibitors of the adoption of digital twins. You want to talk about what you saw there?
Yeah, there's a lot of companies are leveraging these technologies, be it CAD, cloud, industrial IoT platforms, and so forth, to improve business operations. And as I mentioned, by the way, at the end, they end up with a digital twin. So therefore, many companies are benefiting from digital twins in a few ways that are really critical to their operations. The first is digital continuity. So continuing business operations as normal. The other would be improving overall equipment effectiveness. There's a broader interest in certainly manufacturing optimization, but also automating manufacturing optimization. And digital twins help that. The third area would be frontline worker enablement. Again, 75% of the global workforce, that ton of pull through there. And probably the fourth area, which is less on internal manufacturing and more downstream, and that would be on product differentiation. Because if you can provide better insights into the way a product is used, presumably you can not only better service and support your customers with that existing product, but also improve future product iteration as well as the way that product is delivered. And you can differentiate that way. Some challenges for actually doing this in practice.
Actually, Ryan, before you say what the challenges are, why don't we put a poll up for our audience and have them tell us what their challenges. So let's just give it a minute or so, and we'll let them tell us what their challenges are, and then you tell us what your research showed, and we'll see how it correlates.
So data coherence and alignment is one of the biggest challenges, and that's really getting the right data and systems aligned across ET, IT, and OT teams. One of the issues there is that just historically they're working with different vendors, they're working with different systems on different schedules. So it does take time to do that, and then you need to actually do the integration and then figure out, are we aligned in terms of our timeline? What is the right baseline? So it's really alignment as a big one. I'd say also a challenge more industry-wide is around standards and what it takes to get going. So having a common language or baseline of digital twin models that are available on the shelf may help accelerate the time to deployment.
Great. So you see a lot of the inhibitors being more almost the startup cost of getting organized and getting going. I'm sure as we evolve, we'll see additional ones in terms of getting the right information at the right time, or the right digital twin at the right time, and the usability of what is delivered. But I think that comes as the maturity cycle evolves. This time next year we'll have a whole new set of challenges probably. Maybe last topic before we start getting to questions from our audience today. SaaS and the future, how software as a service will either enhance or inhibit the use of digital twins. You want to talk about that?
Yeah, happy to. SaaS categorically greatly lowers the barriers to entry for digital transformation as a whole. And it certainly gets everyone on the same page from a data perspective, because shared data models underpin SaaS deployments typically. Furthermore, cloud-based SaaS alleviates the need for a lot of the in-house development work for deployment and maintenance that you might otherwise need to endure. This also makes those solutions that are SaaS-based much more accessible to the large body of SMB and SME companies, because you don't need to have all this in-house expertise. You also have the latest and greatest software as soon as it's released. There are tons of benefits to
tons of benefits.
Yeah, tons of benefits to SaaS, and I'm hearing, I mean, PTC, all the major companies are going that direction for good reason, because it really does support customers in a good way.
Yeah, for sure. I think the accessibility to data. You still need to do the connectivity and all of the things that you mentioned earlier on, particularly of shop floor data and IoT data of products in the field. But that once you have the connectivity and the data streaming, it lends itself to much better SaaS technology usage and the amount of analytics that you can do on behalf of the customer in real time and or in batch mode, I think really is expanded through the use of SaaS technologies. And I think we're still in this, particularly in the industrial space, we're just at the tipping point. And so I think that will unleash a lot more innovation than we've seen already. Maybe you've said in your opening comments that you expect digital twins, to go from basic to, I forget the term you use for the most advanced. And we said we're in the early stages. How long do you think before we get to the most advanced level in mainstream usage, not the exception?
Yeah, we are starting to see early examples to validate some of the more advanced use cases like virtual commissioning. It's going to be some time before we see that in scale at mass, but they're the most basic forms. I'd say there's tremendous momentum and tailwind behind them, because it's really critical to have better visibility into operations, and that's really what's propelling digitalization in general, is because there's a strong correlation between digitalization and real-time information and accessibility. That's not you're not getting reporting after the fact.
Yeah, and I think maybe my only added comment to that is with the advances being made in technologies like spatial technology, it's not just product digital twin, it's process digital twin, and it's people. And so when you combine people, product, and processes, I think, again, we'll have another wave of value unlock for customers. But I think that's in the development stage, but there's a lot of exciting things happening there as well. Great. Look, this was a great conversation. Your research, for those that haven't read it, I'm sure there'll be a link as part of this webinar, but maybe we'll turn it over now to some Q&A.
Yes, thank you, CK. That was great. I appreciate you and Ryan sharing your insights. Before we do jump into the Q&A, though, I did want to take a look at some of the results from the poll questions that we asked earlier on in the program. So as a reminder, the first question was, what use cases are you most interested in pursuing? And I know, CK, you're in the studio, and Ryan, you're joining us virtually, so not sure if you can see these, but the results were pretty significantly towards manufacturers and improved operational visibility. That was followed up by business executives, asset health and performance optimization. Frontline workers were next with better info at the time and place needed. Then software engineers, rapid development of new applications. And then finally, the least interesting use case, I guess, was seller of assets, customer service, and business model innovation. Anything surprising about those results, Ryan or CK, what you're seeing as far as what the masses are interested in?
It actually seems very consistent with what Ryan had shared with us earlier. I do think the new business models and uses of digital twin in that respect will come. It just requires a more sophisticated implementation of digital twins to actually bring that to life fully. But operational visibility is key across our entire customer base. Ryan, would you agree or disagree?
Completely agree. It's a great validation of what we saw in the research and what we're continuing to see in the market in terms of operational motives driving digital twin forward, especially on product development and process improvement as a whole, because once that is mastered, the idea is that you'd be able to tie that back into the customer side of things, so you can optimize manufacturing with business model focused innovation. And that really is well supported through the changes in manufacturing.
Yeah, for sure.
Great. All right. So the second question that we had, I apologize. There we go. The second question that we had was around the biggest challenges that folks are facing in regards to digital twin. And the number one challenge is identifying and making a business case for digital twin value opportunities. That was 33% of the audience selected that one. That followed up with connecting the dots, creating a digital thread that links the various sources of data across your enterprise, and then maintaining the digital twin, including security, interfaces, connections, data quality, etc. And the last one, the last one that was voted on was delivering the appropriate digital twin data to end users where and when they needed it. But nobody's seeming to have a challenge with getting the digital house in order. This was 0%, implementing a modern digital infrastructure and eliminating technical debt. Again, anything surprising about these results or anything you want to call out?
Yeah, I mean, I would say maybe I don't want to say a flaw in the poll questions, but number one and number, I think, 3 are in essence a core part of getting your digital house in order. First of all, making the business case. Big part of that would be what data do we need and how do we get at it, and then I think the third one was all about data. So to me, the digital house in order is the underpinning of your digital twin strategy. Ryan, any different point of view?
Completely agree. It's a very logical progression to me that says perhaps manufacturers have started to, because CK, as you said, the first couple options are very similar. And you wouldn't be concerned with maintaining a digital twin until you had secured investment into what one. Could be a matter of how the business case is framed and positioned, because as mentioned prior to the pandemic, it was more prevalent to see digital twin initiatives. These days, it's really about improving operations or minimizing downtime. And then, by the way, at the end, we have a digital twin. We saw similar tactics in the augmented reality market, where companies very early on trying to sell smart glasses was really hard because a lot of companies don't have budget for smart glasses. But if you sell a computer or a tablet, there's budget for that. And AR can work with tablets. And some companies have also positioned base computers. So because it's called a computer, IT has budget for that. So it could be a positioning exercise when it comes to getting budget, and then also, of course, driving alignment across teams.
Great answers. Awesome. Okay, so we do have a couple minutes left. I wanted to get to some of these questions that have come in. So as a reminder, if you'd like to ask either CK or Ryan a question, please submit now in the Q&A box. The first one that we had come in, maybe this is a question for CK. What software tools or competencies are required for a minimal viable digital twin?
Good question. I mean, I hate to say it, but it depends answer. It depends on what it is that you're trying to achieve. You just heard from both the poll and from Ryan's comments earlier that there's basic all the way through advanced. And so, if the goal is predictive monitoring or maintenance, well then, if you're a discrete manufacturer, you need the product as designed, both the 3D and the bill of materials. So that would be CAD and PLM. And then I would suggest that you need that product censored in the field. So some level of IoT or connectivity back feeding the twin. And then, it depends on how you want to display that digital twin information. You could do that in using AR or not. And so you could stage the implementation. The full level would be to have both IoT and AR incorporated. If your goal is shop floor, then that's a different set of technology stack. But again, if you physically make something, you need the digital definition, and the place that the digital definition resides in is either in whatever 3D CAD modeling tools you're using, or whatever PLM or product lifecycle management tool. So I think PLM is at the core for discrete manufacturers. Product lifecycle management is probably at the core of everything, and if you don't have, that's why I keep saying, if you don't have that digital house in order, it's very hard to construct the digital twin. And because if you have everything in PLM or the connectors out to other business systems, that ends up being at the heart or the core of your twin. That would be my. It's a long answer, and we could talk about it for a long time. But I'd say, think first about the use cases and the order of use cases that you want to enable with your digital twin strategy.
Awesome, thank you. All right, the next one I think probably is appropriate for you, Ryan. What data rates are required to transmit machine performance wirelessly? Do you have any insight on that?
That's an interesting one. The short answer is the gold standard in manufacturing is certainly sub 10 milliseconds. But for a benchmark for comparison, in public cellular networks, we typically see in the vicinity of 50 to 100 milliseconds, which is reflective of what the human body can process in terms of audio delays. When you start to incorporate video and real-time capability, it actually needs to be less than 10 milliseconds for augmented reality or virtual reality, just as an example. Where it's going, though, in manufacturing and to get true sort of quote-unquote real-time, I think we're actually talking about the vicinity of 1 to 3 milliseconds. That's what's embedded in the standard for robotics to perform an emergency stop. So it is a familiar metric in the world of manufacturing, but definitely sub 10 milliseconds, I think, is a pretty good target.
Perfect. Awesome. Okay, we have a couple more good ones coming in here. How do you see the requirements for physical systems, i.e. robots, production and assembly lines, sensors, etc., changing as digital twin technology becomes more widely adopted? Are the downstream technologies caught up with the needs to enable the widespread use of digital twins? I think either of you are probably more than capable of answering this one. Whoever would like to chime in.
Go ahead, Brian.
Yeah, sure. So is the market prepared for digital twin is what I'm hearing.
Yes.
It's complicated. A lot of the most successful deployments we've seen are point specific. So looking at a particular area of the facility or facet of your business, whether it be product focused, process, or like I said, in manufacturing, so a specific work cell perhaps. And then learning. So test, trial, learn, make sure that one specific use case works, and then expand over time. That's what we're seeing is most successful versus saying, okay, we want to have a full digital replica of everything, plant scale, and that's just really complicated. It takes a ton of lifting, a lot of investment, a lot of alignment. But if you can start small, validate it, and grow, that's where we're seeing a lot of success in the early implementation start.
Yeah, and I would just add to that we're seeing, the smaller systems integrator, like more manufacturing systems integrator, that industry is I'd say going through the next phase of rebirth with how to sensor up lines, what information do you actually need, and then on top of that, like where is all that information going? So I think there's work still to be done there, and it is not simple.
Okay, great. So this one, CK, I think probably for you. What trends are you seeing in the timeline for digital twin or digital transformation ROI back to the business? Is there any kind of average duration for when, someone can see value back to their bottom line?
Yeah, and this is, I hate to be a repeated record. Again, it depends. And so this is why I think doing the business case up front, and identifying what are all the use cases, and then over what time period are we going to implement is critically important, and getting small wins along the way so that you're not asking for investment, and no return. But like I used the Chelly example earlier in my comments, and they got return pretty quickly. Like in an 18-month period, there was some radical changes in performance metrics. Now that was a very tops-down and bottoms-up led effort, but they spent a lot of time before they launched into the effort doing the business plan, identifying what changes needed to happen. So, if you count the pre-planning, then it was probably a longer period of time. But you can get returns, definitely. Once you have the basic infrastructure set up, then you can get, that's probably the longest period of time. And then you can start adding use case after use case and get returns in months, not years.
Let's hope for months, not years. I think everybody would prefer that, right?
Yeah.
All right. How about a question for you, Ryan? Are the AR headsets with 5G connectivity a trigger for digital twin project growth?
In a way, yes. 5G is an interesting nut to crack. The reality, and this is my view, is that there's no single use case that will justify a private wireless investment in manufacturing. However, it's also true that there are certain use cases that simply can't be enabled or are not possible without private wireless. And high-octane video is a good example. Robotics, wireless robotics is another good example. And there's no question that companies want multiple use cases, and I think it's just a matter of the readiness of the device ecosystem as far as being able to support that. Right now, digital twin, in terms of enabling these use cases, it's as long as you have the right software infrastructure and digital data coherence, once the endpoints are available, that standing up new digital twin deployments should be pretty straightforward is the idea.
Great. All right, I think we have time for maybe one more question here, and I think this one I'll send to you, CK. So earlier on, you had mentioned that the digital thread is very important to PTC, maybe more so than the digital twin. The gentleman had a question on clarification in that context. How important is a digital thread for the digital twin? Is digital thread necessary for every digital twin?
Yeah, I completely think digital thread is the underpinning of digital twin, and it's digital threads are maybe the underpinning for digital twins, and so I don't know how you can have a digital twin without a digital thread, whether it's the as designed view of the product, the as manufactured view of the product, or the product out in the field as used, and so again, depending on the use case, but yes, digital thread and different data fields become really the underpinning of a digital twin. The digital twin then just brings that information and that data to life for whatever the particular use case is. So at PTC, we're spending a lot of time on data, the important data, depending on the use case. And because you can swim in a sea of data, and particularly out in manufacturing, data, there's a lot of data, but it was never contextualized. It was never tagged, thinking that anybody would want the real meaning or the real context of it. So there's a lot to sort through in terms of what data is important, and how does it need to be cleansed, and how does it need to be accessed. So that when I say we're spending a lot of time on digital thread, it's that data component, and then making that available and having a common source of truth, I think is fundamental to digital twin.
Any closing thoughts from you, Ryan, on that topic as well, or we're all set?
completely agree. There is no digital twin without digital thread.
Right.
Love it. On that note, I would like to thank you both, Ryan and CK, for making this such an informative webcast and sharing your knowledge with our audience. And thank you to our audience for participating as well. We really hope that you found today's webcast valuable, and we'll come back for future events. As a reminder, as I indicated earlier, this session was recorded, so we will email out this to everybody in the next couple days if you want to follow up and rewatch anything that was discussed. But we thank you for joining us and hope you enjoy the rest of your day.
Thanks, everybody. Thanks, Ryan.
Thank you.